Okay, so we talked about one example for programming, and now we're going to talk about an example with language. Um, so for language, at Marr's levels is going to be again kind of redundant, but we can think about, just a reminder, the computational level is, what the task does a mental system want to perform, and I put want as sort of in quotes, but what problem it needs to solve. Specify the relevant details for solving the problem. What are the inputs? What are the outputs? Representational or algorithmic. It's also called representational level sometimes. How does the system store and manage incoming and outgoing information? How will information be transformed? What are the rules or constraints of that transformation? Is it underdetermined? Um, what are the steps for the transformation to occur? What kind of computations might be involved? And then, of course, implementational is, how is the system physically realized? What's the hardware that's involved? In this case, the brain, what parts of the brain? How does the brain carry out the goals and computations of the cognitive system? So we'll first talk about the computational level. And so, what are we trying to achieve when it comes to using a language? What are the inputs and outputs? And so applying the computational level to language comprehension as well as production in a conversation, uh, we can ask, what are the inputs and outputs? So when trying to comprehend speech, the input might be what we call phonemes, which are basically just sounds, right? Um, and then we can also talk about morphemes because morphemes sort of mean something, but at this raw level where we haven't connected the sounds to anything. They're just called phonemes. Um, you know, so yeah, phonemes are specific to a given language, right? Some phonemes you don't hear certain phonemes in different languages, or you can't hear them and they're not used in that language, that kind of thing. Sorry, what I meant to say is that if for example, Korean people who speak Korean and speak English as a second language, they have trouble with the L and R, la and ra phonemes, and that's because um, there is no distinction between a la and a ra phoneme in Korean. My wife, for example, she speaks Turkish, and she can't. There's no distinction between va and wug and wa, so she'll say that's very vague, right? Or I'm very, right? So she can't really tell the difference. Um, yeah. So, anyways, so the input could be phonemes, but it also could be like printed words if you're reading, or if you're, doing sign language, right? It could be the signs that are specific to that sign language. And then the output could be a verbal response, right? The way just speaking. It could also be signs if you're doing sign language. If you're writing an email, right? It could be an email, or it could be another response. Maybe somebody asks you for help, and your response is to help, right? But importantly, that would just be comprehension. That's just the speech comprehension part, and there's no production involved. Uh, but in order for there to be some sort of back and forth dialogue, there has to be a system uh, for how the sounds should get combined to make speech. And that those rules have to be followed by both people, of course, but it has to be meaningful. Those sounds have to be meaningful to both people involved. So there must be a system of rules for combining for combining sounds into words. And in this case, it would be morphemes. So morphemes are just uh, sounds that mean something. So this could be like a prefix or a suffix, or just a word, right? And then, so there has to be a system for how to combine sounds or morphemes into each other to make words. And then there also have to be a system for combining words into sentences, and we call this syntax. Um, so the fact that you know to say, I went to the store instead of I goed to the store, right? We know that the to go verb is conjugated a certain way depending on what the subject is, and as well as if it's past tense or present tense or future tense. That's syntax, right? And so yeah, but these utterances themselves don't necessarily mean anything to anybody, right? Um, they're arbitrary in a sense. They mean something to you and presumably the person you're talking to. But the reason they mean something to both of you is because they refer to a system of meaningful units, right? So uh, they're symbols that refer to something, and these symbols need to represent something meaningful. And so, as such, there needs to be an additional system of meaning or semantics that the symbols can represent. And so, the next level then might be how does, well, the computational level is figuring out what the problem is. And you could maybe think that the problem of speech or of language should be tied to figuring out what's going on, in the intervening stage between input and output. So now we'll talk about the algorithmic stage, right? So in the algorithmic level, you can say like I mean, we're getting back to it, right? How does the mind link raw sensory information to meaning, right? So this is called a spectrogram. Um, if you were to record your voice and then sort of try to look at the sound waves maybe, or the pattern visually, you would get something like this. And this is the spectrogram for the utterance, I can see you, right? And how do we get that raw sound, all that raw sound information to mean what we think it means? And so again, we need to some system of rules to combine sounds, and in this case, meaningful sounds. And as I said, morphemes are the elementary units of meaning. So this could be words, but it could also be prefixes or suffixes. So I think in this example, independently, um, in would be a phoneme, or sorry, a morpheme. Depend would be a morpheme. Ent, I guess ent would be also a morpheme, and lee would make it also a morpheme because independent, for example, means one thing, but then when you add ly, it turns it into I think an adverb, and so it's that sound changes the meaning, so it's a meaningful unit of sound. And so one thing you need to do is, figure out how those morphemes get combined in a specific way. And there are rules for how to combine those morphemes. And everybody knows them implicitly, but most people don't know them explicitly, right? You use language all the time. You know how morphemes are supposed to combine, but you couldn't really tell me necessarily how they combine or what those rules actually are, I should say. And the mind needs some sort of it needs to represent these units, right? It needs to somehow represent morphemes and the rules of these morphemes. So the algorithm for combining these morphemes. Whereas syntax is about building more complex structures of meaning, like so sentences instead of words. And so here is what's called a syntax tree. Let's see, I think this is supposed to be, it says subject verb phrase at the top, but I think it should mean sentence. I don't know why it says subject verb phrase. So we have a sentence that has a noun phrase, a verb, and a prepositional phrase, right? And so the mind needs to represent these more complex ideas, um, and these methods or rules for combining these words into sentences, right? And I don't know really much about syntax, at least not explicitly. Of course, I know syntax implicitly, like everybody does, but there are rules for how how words get combined. And, for example, a sentence can have a noun phrase, a verb, and a prepositional phrase, but you know, for example, that often the verb can't come before the noun phrase, at least not in English, right? So these are rules that we have for combining sentences. And we also need to represent the fact that the cat is a noun phrase and not a verb phrase, right? So we also need to not just represent the rules for combining words, but we need to know what category, uh, grammatical category a given word is should be categorized as, right? Okay. Now, of course, as I said, we need a system of semantics, right? So we need to figure out, how maybe are these meaning represent. We need to obviously represent the meaning of these things, and so we could ask, how are the representations, semantic representations organized, right? So the mind needs to represent concepts as well as their relations to each other, right? So we can talk about maybe there's not only is there a rules for combining sounds into words and words into sentences, but then there's sort of a semantic network that's attached to the lexical system, so to speak. And that's a whole other um, uh, that's a whole other subject of research, is the semantics as well as the lexical properties of stuff. So there's a lot of research figuring out how are concepts organized in the mind. Are they organized hierarchically or not hierarchically, right? So that's one example. Okay, and then to talk about implementational, what's the hardware involved, what parts of the brain are involved. Now, I'm not sure how much of this is known, and I certainly don't know much about it, but um, I do know that, for example, if you have damage, maybe because of a stroke, if you have brain damage to right here, which is called Broca's area, you have trouble producing speech, but you are good at comprehending speech. Your comprehension is intact, but you have trouble producing words. Whereas when Wernicke's area is damaged, they have no problem. These patients have no problem speaking, but they usually don't make any sense. And likewise, their comprehension skills are also, um, damaged quite a bit. Okay, so just to wrap this up, you know, when we apply Marr's levels to language, we have figuring out what we need to defining the problem, what the input and output of the problem are. And so we think, okay, there's some sensory signals that come in. We need to figure out what they mean. And then we need to maybe respond back with an utterance or a behavior. And then at the algorithmic level, we need to figure out what needs to be represented, what kind of rules need to be represented, and is it possible for the rules to work, right? Is there a system of syntax and semantics that would allow for us to actually represent it faithfully? And then the implementational is about the brain. So maybe there's dual streams, right? We have different parts of the brain that are um, responsible for different sub-functions of language. We could also talk about the visual system, the motor system, and the vocal tract if we wanted to as well, right? Okay, and the last thing I wanted to say, sorry, went a little over, is that I would argue that most of cognitive science focuses on the representational or algorithmic level. That isn't to say that we don't care about the brain or this sort of problem, but the main focus is to understand how the mind works. And if we have to study the brain or we have to think about the mind on a more computational level and defining the problem, we do, but the goal is to understand how the mind works. So most of cognitive science deals with that. Okay, and then on the next video, we'll talk a little bit more, and we'll just have one more video, which is a little bit more big picture. Okay.